So now let me make a quick overview of the processing methods available at this time when I record these videos. So later, perhaps there will be more methods available here. So let me just remove all the methods I have selected so far, and then show which methods are available. Well, Savitsky-Goulet, it's a Savitsky-Goulet filtering. You can see that you can change the filter widths. It's a odd number. And then for certain filter widths, you can select a polynomial degree, either linear, quadratic, or cubic polynomial. And you can also use a derivative. If derivative is 0, it means no derivative will be actually computed. It will be just smoothing. And then derivative 1 by default is available for any polynomial. If you want to use a second derivative, you need to select polynomial of degree 2 or 3, like this, for example. Then you can see this is the result. Okay. Normalization, there are 4 different options for normalization available: standard normal variate, unit area, aka L1 norm, then length, unit length normalization, it's Euclidean norm or L2 norm, and then the variable normalization, it's normalization to a height of a given variable. For example, if you have a characteristic peak for internal standard, you can use this variable index. If you have a lot of variables, like in my case, I have many, like almost 2000 variables here, you can move it with mouse. And then if you want to make a final selection, use keyboard. So if you click here and then start using keyboard, like arrow left or arrow right, this is actually true for any interface. You can always use a keyboard for the interface elements in order to make a more fine selection. Okay. Now the scaling. Scaling actually consists of 2 operations. It's centering and scaling. It's applied to columns of your data set. You can see that for centering we have 2 options: mean or median centering. And then for the scaling, it can be standard deviation. It can be interquartile range, difference between third and first quartiles. It can be full range, difference between max and mean. And then it can be also Pareto scaling, which is also using standard deviation, but square root of standard deviation, right? The baseline corrections, there are 2 methods. It's extended multiplicative scatter correction. Here you can define a polynomial. If polynomial is 0, it will use just the standard MSC. So it means it will correct offset and slope of your baseline. So let me actually load Tcator data, because in this case we have this scatter effect, and it will be easier to demonstrate the baseline correction here. So for example, if I use just, let me remove the spikes first. Remove it and then use baseline correction. So MSC with 0, it's just multiplicative scatter correction, right? So you can see how it looks like. If you use a polynomial, it can be polynomial between 1 and 5. It adds some polynomial terms. For example, if I use polynomial of degree 2, you can see this is how it looks like. Okay. What are polynomial terms and all the details about the extended multiplicative scatter correction or any other methods you can find in this reference, which I'm going to show in a minute. Okay. Another method for baseline correction is called asymmetric least squares, also a pretty good method. And then you can see there are actually 2 parameters, it's lambda and penalty. But to let you choose penalty from a wider range, you need also to select the range. For example, if penalty range is 1, then you can see that it's 0.1, 0.2, 0.3, 0.4, and so on. If penalty range is 0.1, you can see it's like a more fine selection. Then you can also have penalty range of 0.01. So for most of the cases, these 3 ranges will work pretty well. And then you have lambda between 7 and 1. Okay. Let me just click save. And then this is how it looks like. Then trim tails, it's a very simple option. You simply trim tails on the left and on the right. You can also have several trimming tails, but be careful when you move them, because if you, let me just make several trimming tails like this, then you can see every next trimming is on top of the previous one, right? So I cannot make it smaller than 16 in this case, right? Smaller than 15. So let me just select it. And then you can see when I move it, you can see they change, because to avoid any inconsistency, they change this value. So if you move your trimming, you need to change the trimming values again, just to avoid any inconsistency problem. Okay. Then finally, spike removing. I already showed it several times. It has 2 parameters: threshold, it's how sensitive it is to distinguish between the real spikes and, for example, some noise or some natural variation of the spectra. And Twindo tells how many neighbors to tell around the spike in order to compute the values for the replacement. Okay. So these are the main methods. And if you want to know more about which algorithms and which theory they are based on, just download this reference file. So let me show it. So you can see reference PDF. And if you open it, you can see what is inside, right? So it's a list of the methods with some explanation. For example, for normalization, you have SNV, you have area, and so on and so forth. Scaling, baseline correction, so a more detailed description, but also references, right? So if you, for example, want to reference, to cite some of these methods that you use, you can find the main references here. Okay. So this is almost it. And the last thing, which is also important, is that, as I said, you can use preprocessing as a part of many other apps. Let me just demonstrate it quickly. If I, for example, run principal component analysis, right, and let me open, for example, the same SPC files that I used before. And then you can see after I loaded this file, there is a preprocessing step, which I can skip if I don't need preprocessing. I can load. It means I will load the preprocessing model that I just created, or I can create it from the scratch. If I click create, you will get the same interface here, like you just seen, but it's a model window, so you can close it. You can see here, right? If you click load, then you will be able to load this model that you just created. In my case, it's this one. And then it will be applied automatically. And then you can do your PCA model, for example, like this. Like this. So this is the PCA model made for the preprocessed data. And likewise, you can see what is inside your preprocessing model and so on. Okay. So this is actually it about preprocessing. I hope you will enjoy it.